create a HashMap. Okay, how we are going to create the HashMap? Like this. We'll create map equal to new HashMap, right? So this is the way we create the HashMap, right? So we'll import it. So let's import. So this is my class name, right? And I have imported the HashMap here. Okay, so that I can use this map further in the program, right? Means we have this HashMap. Sorry, M should be in the capital. Okay, HashMap. Okay, so this is our HashMap, right? And if you're writing the HashMap, right, it means you have to import the inbuilt class, right? And that is why Java HashMap is called Java inbuilt HashMap, because this class is already designed. How we are going to use if we are not implementing our own, right? So first of all, we used to create a HashMap, right? This is our map object, right? Then what we will do after creating the HashMap, right? After creating the map, what we will do? We'll put some value on the map. Let's suppose I'll put the some value, right? So the messages are, we can use put, right? So you can see there will be key and some value will be there. Let's suppose as a key I will take name, right? And for the value I will use, let's suppose I'll call it Michael, right? Name is Michael. Name as a key and value as a Michael. We can say that. Let's suppose I'll put another value, key value, and this is nothing but our let's suppose say country. Okay, I'm just taking for the example so you can understand. And here I will take USA. Okay, now if you will print the value what we have in the map, right? So just you will write what sys out and you will write the map. This is our map object. Now I want to check what is the data we have on the map, right? So if you will run this program, right, you can see here, right, what we are getting. The map we have is name is Michael and country is USA. So this is the key and this is your value, right? So that we have added here, right? Means we have to implement the put method also, right? If you observe, we have to write put method, get method, those things. Let's suppose I want to put another value, right? Updated value I want to put here, right? I want to replace this value. Okay, so let's suppose for now just take this line of code and let's enter here. Just we will update the value. Okay, so before that, after that, let's suppose I'll give the name Mia. Okay, and she is from India. Okay, now check if I will comment this line of code. Okay, and I will run this code. So what will come? The updated value will come. The name is Mia and country is India, but we have also added this one. So where this data will go, right? Means we have added this value, but this data is updated now here. Means the map will remove the old value, that is Michael, because the key is same. If the key is same, right, we will take the latest value and will remove the previous value. Okay, so when we are adding the new value, right, let's suppose if I want to see which value it is removing, just think that if I'll write sys out, okay, and I will put this value here. Okay, I want to check what are which was the latest value that we have replaced. Means we have replaced the Michael, so should it print the value or not, right? Let's check. Yeah, the latest value that we have replaced is Michael with Mia, and that you can see. Similarly, if you will put, this is a Java interview question, you know, if you are going for the Java interview, somebody will ask you if we will print the map value into the sys out, what you will get? You will get the value that we are replacing, the latest value that we are replacing, right? So as you can see, understand? After that we are printing the map, and so we are getting what? we are getting these two value. Name is Mia and country is India. Understand? So the very first step for the put method is we can put the values in key value pair, right? So the map will store value, key and value, key and value. How? Let's suppose. So I can, for now, what I will do, I will comment this line of this piece of code, okay? Or we can keep it, don't worry, leave it. Now, if I don't want to print this piece of code, right, this line of code, I want to just, or you can keep it, don't worry. You want to check the value. What is the value? Let's suppose get, you know the key. I want to check key. Key is name. What is the name? We can find the name. Run it. You will see the name is coming Mia. The latest value on the map is Mia. So you are getting Mia here, right? Similarly, if we'll pass the key as a what we call another key, that is country, right? That we have added. Let's add it the country. Run it. Okay. So it is becoming India. If you know the key, you can find the values, correct? Means first we have to implement the put method, then we have to implement the get method, right? Let's suppose on this list, right, that we are seeing, I want to delete some value, right? Let's suppose on the map I want to remove a key value pair, right? So just I will pass the name. Let's suppose I will remove the name. So if we'll pass the key and if we will print it, right? Let's suppose after printing, after deleting, I want to see what is the value is there, right? Let's run it. Now you see previously the value was what we have, name, Mia and country, two values we have, right? We were printing also, we are seeing this value, but after that we are removing line number 20, and so only India left because we have removed what? We have to map dot remove is name, remove the name. So we have removed the name. So map contains only one value, that is this Mia, right? So either you can put alone like this, right, or you can put in the sysout, right? It should return the value. Okay, so this feature we are going to not going to use, but we have to use this functionality will be same, only we have to not to use the inbuilt function, inbuilt method, inbuilt class, that is HashMap we have in the java.util package. We will create our own HashMap, right? I hope you understand till now, and I have taken your 10 minutes, okay, but I want to give you the background so you can understand better in the further class. Okay, so if one of you are beginner, right, it might help you. Okay, and this is very good for the interview perspective. So let's learn it. Okay, let's continue how to implement by customizing the you can say our customizing the class, right? If we'll write the our own map class, means we are not going to use it. Let's suppose we are not going to use it, means we have to create our own class. It means we have to define what? Like class as map, and then you have to define the class, right, like this. But for that you have to write the methods. How? Let's see. You will create the method like this, then you have to write the method get method also, right? So create the get method and then the remove method, like this. Just for example I'm saying like this, you have to create the method. So this is the thing we have given, right, and we have to implement it. How we are going to implement it, that we will see. So Leetcode is given this skeleton to you, means implement your map, my HashMap. You have to implement, and behind that they will use the test cases, like they will try to see these things and the result expected, they can see the expected result is coming or not. Okay, so I hope you understand. Let's implement the functionality of the HashMap to 10,000, right? Because it's a prime number, right? And in hash based data structure, like where we use hashing technique, right, that we call as a hash map, right? So we are using a prime number as a size of the bucket array that helps in achieving better hash value distribution, and it will reduce the collision, right? So what is collision? You know, the hash map collision, it's a very important question for the interview. What is hash map collision? So let's understand what is collision, right? So collision in hash table, we can say when you has a key and you turn it into an array index, right? Let's suppose we have given index, right? And this index is, we can take what, key, and we'll take mod size. Can we say that? So the key, you turn it into an array index, right? So to find the index, you should have a key, and that you can take the mod with the size, right? So if two different key produce the same index, let's suppose if there is some keys there and there are two keys there that produces the same index, right? Means we have seen the key, right? Means there was a name is there, and there is a what was that, country, right? We have used. So if name and country, let's suppose there is two keys there, right? And both key represents the same index, right? So they want to live in the same bucket, correct? Because they have the same index they are producing, right? Means the two different keys produces the same index, right? And so they want to live in the same bucket, right? So the event that is happening is called collision, right? Let's suppose I'll take a key, okay? Let's suppose the hashing formula we are taking here, let's suppose you are taking similar to this one, right? And there is some index is coming, right? Index that we are producing here. So this is the index I'm talking about, okay, here. And this is the formula that is called hashing, okay? And key we will use here. Let's suppose we are taking 3. So 3, and we'll take let's suppose size is 10, right? So we have size is 10, okay? So what will it come? It will come 3, right? It will come 3. So the index will get produced is 3. Let's suppose we have 13, right? So if we'll take 13 mod 10, what will come? 3. So this is also coming 3. So both index is at one place, right? So if we do nothing special, right? So the second value would override the first, right? Like we have used the previously what key we have uses and value pair we have uses, right? We have taken the name and we have taken Michael, right? And then again we have used the same key, but we have taken in the place of Michael we have used Mia, right? So Mia have replaced this value, correct? So if we'll not do anything special here because the index is same, right? Then collision will happen and automatically this entry will be replaced, right? This value will be replaced, the value of this you can say index will be replaced with this one, the latest one, correct? So every hash table needs a collision handling strategy. There should be some strategy to handle the collision. I hope you understand, right? So now understand how HashMap handles the collision, right? How? Let's understand how handles collisions, correct? Can we say that? How handles? So if we will use a separate chain with singly linked list, right? Let's suppose if we have some bucket is there, let's suppose we have a bucket. Can we say that this is a bucket and bucket contains 3, okay? So bucket at index 3 we have two things, let's suppose 3 and 7 we have here, okay? And we'll take 13 and next is 42, right? So if we'll represent this will be look like the bucket we have here is 3 7 we have, right? And next it is pointing to 13 42, right? Can we say that? We can say that. So next is nothing but null, right? Means you have to take a single linked list, right? It means the index at 3 is having some value like this, and 13 42 we have sub index, means at this index we have two things, this one and this one, means this bucket will understand it will point the index as a singly linked list, means each bucket will store a head of linked list, you can say as a head of linked list, right? So the bucket that we will use in the HashMap, right, that will store the head of the linked list. Can we say that? So if collision occurs, we just insert the key value pairs, right? We will insert the key value pairs. If any collision will happen, we'll add the next. This is null, we'll put here. The next value will get added on the front of the list, right? So each time we'll keep adding the value. I hope you understand, right? So when we'll call get and remove, right, walk that list to find the key, right? So with, let's suppose we have 10,000 operations we have, right, and bucket 10 to the power 10,000, like this type we can say. Let's suppose 10,000 operations you have, right, and bucket size you have is what, 1007, right? It's a prime number, right? So the average linked list length is load factor. You know the load factor is less than equal to, it's approximately 1, we can say that, right? So we'll do get or put or remove, it still become O of what, 1 in average size. I hope this is little complex things, right, but I'm trying to help you in very simple way, right? Means what I'm trying to say, let's understand again. So we have a bucket, can we say that? We have a bucket, and at index 3, right, we will have we will use a linked list, right? So at index 3 we have seen that two collision is happening, right? Means at 3, index 3 we have we can say 3 and 7 was there. So this is our key, right? And we have seen that the same index same index is getting by this key also, means two key we have used. What are the two keys are there? 3 and 13 both produces same index 3, right? And so we will use the singly linked list to store this to handle this collision, and we can say null this, right? Means each bucket, what, each bucket will store the head of the this is the head of the you can say linked list, right? So if a collision occurs, we insert a new key value pair each time, right, into the front of the list. So we can use what, get and remove we will use, right? That small list to find the, this is small list to find the value, right? So you can use these things. Okay, I hope you understand. It's very simple, guys. Okay, so as we have understand, right, what we need to do, we have to create a bucket, right? So how we'll create the bucket? So let's say I'll create a node, a class that we'll see later, and this node will contain what, bucket, right? So this is our buckets, we can say that, and we will use this bucket to store the values, right? So the node class we have to define. How we're going to define the node class? So just you can create here, you can just give a private, right, and the give the name static, and we'll say class, and we'll say node. We can write a static class, right, inside a class, correct? You have to define the node. What is node here? So node is a class, custom class that will store two things. There should be a key should be there, and another should be value, that we have seen, right? Key and value will be there, 3 and some value 7, 13 and 42, like that we have to store here, right? And the node that points to the next, right, next node, that is null, we can say that. This class should contain what do we call constructor, right? There should be a parameterized constructor that will initialize the key value and next, right? So let's suppose I'll have a default constructor that will not a default parameterized constructor that will contain the key, and there should be int value, right? And so we'll store we call this dot key equal to key and this dot value equal to p. Can we say that? So we will initialize this key and value pair. Now we have to initialize the bucket. How we are going to initialize? So when the we'll write my map, right? New my map, right? That time it will get initialized, right? How? We'll call new and we'll pass the size, right? What is the size of the node? By default we'll take 1007, right? That is our size. Can we say that? It will get initialized. Now we know that we have to define a what we call a has generator, right? What is the has key, right? Has value we can say of the key. So we can find the index. We'll say private int and we'll call it has. It will store two things. It will generate the key. We will pass the key and we will generate it. Will return as we have seen with the mode, right? And we'll call it size, right? So each time we have to put the unique key, right? And the chances of generating the has value will be it may create you the collisions, right? And so we have taken the size like this, right? Now understand. So now we have to implement the put method, right? So let's understand how to implement. So very first we have the again key and value pair we have given, right? So let's find how we are going to find the index, right? You know the index we will find how. We'll have the has and we'll pass the key. So if we'll pass this key, we'll get the index, correct? Then we have to define the node and there should be one head, right? So each time we'll take a key value pair that is called node and we'll store the buckets at index, means the head of the what we call will store at the bucket. How? Take a node, call it a current, and let's put the head onto the front, right? So for that you will write what? Current not equal to null, right? If it is the current is not null, means we have some data on the current. So we'll say current dot key is equal to the given key we have, right? If it is equal, just write current dot value equal to value. Can we say that? We can say that, right? Value means update the existing one. Update existing value, correct? We can update. Else what we will do? Current equal to, we have seen, right? We have updated the value, right? Michael to Meva. Otherwise we'll move to the next. We'll add to the next value. Next will get stored, correct? Then now insert new node at the beginning, right? So to, let's suppose insert new node at the beginning. How we are going to do? You will create node, new node, and we'll say new node and we'll pass key and value, correct? Two things we will pass. Then we'll say new node, right? New node dot next, new node dot next, and we'll put it here, okay? And we'll pass two things, key and the value. Can we say that? Next we'll put this like this, right? Now on the buckets, we'll pass what? Index equal to head. Head. So new node we have taken what? En value, then new node dot next will store the head, okay, and the bucket. Okay, so new node we will store, right? New node will store here. Understand? So what we have done here, let's understand. Oh, sorry, we have a bug here. Only will pass the head, right? So what we need to do now, understand? So in very first, what we need to do, we are doing what? We are generating the hash value, right? Then we'll get the head, right? So in the next step, we'll say get the head of the chain at this bucket, correct? And then start traversing the linked list, right? How? You have the current, the head will store at current, right? Now we'll check the if current is not null, means start traversing the linked list at that bucket from the current, right? If the key exists, right, just update its value. Can we say that? Yes. And then return early so we don't insert again, right? Then we'll move to the current equal to current.next. Next, what we need to do, if key not found, means we have to insert a new node at the head of the chain. For that, we'll create the new node. Then we'll create the next, right? And we'll point new node to the current head, right? And then we'll add the current index, will store what? New node. Understands? So let's suppose we will insert 3 key value pair in the HashMap, right? How? Let's suppose we have our own map is there, right? And on this map, we'll put the value. How? Let's suppose we'll call 10 and 100. Can we say that? We can take this value. Then on the same map, we'll store similar to value. Let's suppose same we will add 20 and we'll call 200. Let's suppose this time 200. Next we'll map dot put and we'll pass the value 10 and 500, right? We'll store, means we want to update here a key at key equal to 10. What? The value should be updated from 100 to 500, means previously it was 100, now it should be 500. Till here, if we'll find the get method, through the get method, get at 20, it will give 200, right? And get at 10 will get 100, not 500. What here, if we'll do at key equal to 10, we'll get 500. Understand? So assume the size is we have is 10, right? For simplicity, not for 10,007 that we are taking, not for this one. Just assume the value is 10, size is 10 that we are talking about, right? Not the this one, just for simplicity, right? So that the hash, if we'll do the hash. So for the hash, let's suppose call key. What it will give you? It will give you key, and we take the mod size, right? So what is the key is here? So key is 10. Let's suppose when we are doing put 10 and 100, what we are getting here? We call this index. Sorry, we call this as a index. Can we say that index, right? When we are putting, we want to get the index. Index is how we are getting 10 mod 10, and it will give you 0. Means bucket 0 is empty, so we can create a node, right? So we can say bucket is what? 0 or empty. So let's create a node. How we are going to create the node? You will write node and we'll say 10 and 100, right? And it will point to the next node, that is nothing but null. Can we say that? Means at, let's suppose if we'll write the HashMap, right, like this. So at very first index, that is called 0, let's suppose, right? It will point like this as a 10 and 100, right? Similarly 1 2 3 is there like this. So each will point to null, 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 like this. So this is your nothing but hash table. Hash table, can we say that? We can say that, right? Let's understand. Give me a second, let's clean it. Okay, so let's understand. In the next step we are going to put what? 20 and 200, correct? When going to put 20 200, what is the index? Index will become what? 20 mod 10 will get what? 0. So bucket 0 that we are talking about, bucket 0 is already have what? We have already have 10 and 100, right? 10 and 100, yeah. So first we have taken 10 and 100, right? Then 500. Okay, so this time if it is already value we have, means what happened? We have a collision here. Can we say that? Means we have got the same index. At the same index already data we have is this. So here collision will happen. So we will insert these 20 and 200, right, at the head. How? So we are doing what? New, this is your new node, right? So new node will create. How we are creating the new node? Using the key and value. So new node is nothing but 20 and 200, and that is called next. We are doing next, and at this next what we will put? We'll put the head. And what is we have at head? Head we have 10 and 100, 10 and 100, correct? So if you will represent this in the table, how now it will look like? Let's suppose we have a couple of value we have, right? So at here we'll say at 0 on the thing, what we have on the head, we have 20 200. Next node is what we have? 10 and 100. So next we'll call at index 1 and index 0 we have this a small linked list, right? In the next what we have? Null. I hope you understand, right? So these become null till the n. How many is there? 0 to 9, right? Till the 9th index, we can say till the 9th will also come null. I hope you understand, right? So let's understand at the last what will happen, right? Now we have also added the third value. We want to put 10 and 500. Can we say that? We want to put 10 and 500. Now it's job to update the value. If the key is already there, means we have what we have added? 10 and 100, right? Then we have a 20 and 200, like that we have added, I think, right? So and then we are going to add 10 and this one, right? So we look for the key 10 first, right? So let's start. How we are going to start at 2 and 20, because that is our head is there, right? And it's not, the key is not 10 this time, right? So move it to the next one here. Can we say that? Here it matches. How? It was 20 200. The first is there, the next is what? 10 and 200, and next we have null, or we can say leave it for now. Okay, just leave it. So at 0, let's suppose if we will find this value, correct, what index will come? So 10 mod 10 is 0, and that is our nothing but the index calculation, right? So you will get the index 0. It means we are not talking about the next one, we are talking about the index 0. So at index 0, first value we have what? 20 and 200, correct? So if we have 20 and 200, then what we should do? This time it will first check this value. Start with 20 and 200. The not the key is 10, so move to the next one, move to here. Is the key 10? Yes, we find the match, right? Now update this value. We'll update this one here directly. Means at index 0, now it will point to 20, 200, but it will become 10 and 500. If it is 100, it was 100, right? So it will become like this. It will update. I hope you understand, right? So if you tell me what is the final look for the bucket 0. So we have bucket 0 linked list. Can we say that? Linked list. And it will look like at 0 we have node contain 20 and 200, then node contain 10, 500. Next we have is null. Understand, right? And other buckets is containing, let's suppose 1 contains here null, in this case 2 contains null, 3 contains null, till where? Till 9 index, because the size is what? 10. So 0 to 9, right? And this is your nothing but your bucket, this bucket that we are talking about. I hope you understand, right? It means when we will add key and value, we have to generate the index, then bucket at index will take the head, right? And will check the head, right? So bucket, this is your index, let's suppose, and at index you will check the current will be where? This is your current will be here, right? So it will point to the very first value, right? And that will call, let's say 20 and 200, then it was 10 and 100 or 500, this time is 500, right? So it will check, the value will get checked, right? So if the current is not null, right, this is not null, here it is null, right? So till this is the current will move from here to here, it will keep moving, right? Because we are doing what? Current dot next is time, so it will keep moving, okay? And it will, until we will not reach to the here, it will keep moving. So if not null, just check the key matching, no, next check the next node check, yes, key matches, update this value. Understand? Otherwise, and also stop it. Then we have node, right? Node is new node, equal to new node, key and value pair is there, right? If these are not matching, let's suppose something coming 330 and 400 is coming as a new node, this is, let's suppose this is your new node, so it will check the index, right? Index is coming or not? Index is not matching, right? But that key we have added, we have got the same index, let's suppose, so it will not update the value, it will add to the here, the front it will add where? At the head. So new node dot next, it next will become the head, right? And bucket at index will update the new node, so this will get updated now, not here, it will get updated here at this index. Are you with me? Are you with me or not? You are with me, I know, because this time there will be some node, let's suppose there is node 1 is there, then node 2 is there, right? Like that. Whenever new node is coming, we'll check the value, right? If value is not matching, key is not matching, we'll move to the here, we'll create our new node, right? And this new node will points to what? Its next is nothing but the head. Where is the head? Head is here, so we'll put the entire thing here, okay? Head and bucket at index I will point to this one. Understand? So like that we'll keep moving ahead. So next we have a get method, where we'll find first, we'll use the method has the key, right? We'll use and we'll find the what we call the index, right? And we'll calculate the index in the bucket using, has key percent, the size, right, that we have already created the method, right, as method. From there we'll get the index, right? Then we'll go to the bucket. Where we'll go? We'll go to the bucket, right? First we'll go to the bucket at index, and we'll get the at what is we have at index I, that is called our current, right, at that index. If the current is not null, right, if the current is not null, we'll check what current dot key is equal to key. It means we have got the key, just return the value. Means we have to do what? We have to traverse the list here, right? To traverse the list, entire list, you have to check if current is not null. If current is not null, then we'll validate the things, right? But before that, you have to get the current from where? From the bucket. Go to the bucket, find the current, means retrieve the head of the node of the linked list from that bucket, and the key might exist here, right? So you will get it from here. Okay, so it can be maybe at this index, maybe it's null, right? And that is why we have to make a condition that current should not be null. If it is null, we'll not do anything, we'll return -1. We don't have anything. Okay, then what we will do? Check the key in the with the current, right? The current key is equal to key. If it is, then return found value. Can we say that? And then if it is not match, move to next node and then check. Correct? So let's suppose we have a bucket and it has a index 0, right? So you have passed a key and that gives you index 0. Can we say that? So at index here, let's call it 10, right? We have 10 and 20, 200, we can say that, right? We have here element. Then we have, let's suppose 20 we have and 200 we have. Okay, so somebody, anyhow, what is happening, somebody, what we are doing, he is doing, this is key and value pair, right? And this is null. Yeah, next is null. So you got the current is at where? At this point. Let's suppose at index 0 we got the current, means current is at here. This is your current. Then current is null? No, it is not null. It means there is key. Check the key, and this is the key that we have passed. Is it equal? If yes, let's suppose we are passing 10, right? So we found it here itself, right? But if we'll take in 20, so this is not matched, so we'll move to the next. So it is not matching, so we will not go here. We'll go where? The next node. How? Current dot next. So we'll update current from the current dot next. We'll move here. We'll check the value. If the key is matching, return this value, right? Like this we will do, and successfully we will return the value. Otherwise, if the key is not present, return -1. Do not do anything. So now understand how we are going to use the next method. Let's understand the method remove. So very first step, what we have to do, we have to find the index, right? Means we have to hash the key and you will get the index. Next step, you will find the current from the bucket, right? And then you will find the previous, right? If previous is null. So let's understand how the remove will work, right? So very first step is we will get the key, right? And we'll find the what? Index, right? So you know how we are going to find the index, right? Then we'll have the bucket. So let's suppose at bucket we have found the index 0 now, right? So at this index there's some node will be there, right? Some node is there, correct? We know. So you will get the current, means at this index node is, the current is here, right? So what is the previous? So previous will take as a null itself here, right? Because when the current will go here, we will update our previous. This is our previous, right? So this is your previous, so this is your next, or you can say current. So very first step, when we'll reach here, we'll say current not null, check the current key is equal, is this key and this value, so this key is matching with the given key, right? This key, it is matching. If it is matching, we will say previous is null, right? We have taken previous null, yeah, true. Just update bucket at index is what? Current dot next, means at this index is what? Not this value. We have to remove this, so just remove this. There is only one node left, this node is left, and for that you will do what? This is, it was, the current was here, right? Now current we have moved to here, so you will do current dot next, means remove the head node. This is the head node, so we will remove it. Then do previous dot next, right? Means we know that previous we have we have to take, right? So previous dot next will put the current, will come here, right? And will return here, means we'll remove the non head node from here, and we'll update the previous dot next is a current dot next. Can we say that? It will become, and then we'll update the previous is current and current is current dot next. So let's understand by an example, because if I speak like that, you will not understand, right? You just think that as we have understood the bucket at index 0, right? Bucket at index 0, we have keep some value. Let's suppose it's called 20 and 200 we have, correct? Node. Then next node contain is 10 and this is 500, right? Now the next added that we have added is 30 and let's suppose call 300, right? Can we say that? So this is the bucket 0 contains, right? Bucket at index 0. So this is the list we have given, linked list we have given, right? So let's suppose we want to remove what? Somebody putting remove what? Remove 20. You want to remove the 20, right? It means what we need to do, let's suppose call, we have previous is null initially, right? Current at current keys we can say is 20. Is it equal to 20, right? Yes, the current is where? At here, right? Current is at here, right? So if current key equal to 20, yes, that is true, just update it. Update, what we have to update? Bucket at 0, means bucket at 0 meant that index is what? Current dot next. So we are doing here at this line, correct? The previous is null, right? Current dot key is matching the key that we are doing here, right? So it's time to update what? Bucket at index is, we have removed here, means we will not directly remove. How we will remove that? To just the pointer that we have, it will not put here, it will move from here to, it will point to here, you know, the linked list, right? So in the linked list we have a node, so this is your next and this is your what? Nothing. Understand? So if the bucket at index contains the head of the node, right, means it will point to like this. So this is not going to point here, it will point to next, that we are doing where? At here. We will remove this piece, this current is not more here, no more here. Now current is at here. Understand? Just by doing this. Bucket at index is current dot next. I hope you understand, right? So this is our complete code, means first we will define the size, right? Then the bucket, then we'll define the node class, then we'll define the map, then the HashMap, then we'll define the put method, right? Then we have what? Get method we have, right? Like this, and then that's all done. Use the remove now. So you define the remove method. I hope you understand. If you have any doubt in this video, please let me know in the comment section. Okay, thank you guys, thank you for watching this video. I'll see you in the next one.
Thank you guys, thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.